To set up the experiment, we are going to add 5 milliliters of manganese 2 sulfate to each of the wells A1, A2, and A3. In this next step, we're going to add 5 milliliters of potassium permanganate to each of wells B1, B2, and B3. In this next step, we are going to add sulfuric acid solution of a concentration of 6 molar to well plate A2. We're going to add 5 milliliters of the solution. Next, we will add 5 milliliters of a 6 molar sodium hydroxide solution to B2. In this next step, we're going to add several drops of the potassium permanganate solution to well A2, stirring it with a toothpick to make sure that the reaction goes to completion. And we'll add a few more drops for good measure. As you can see in the video, it is definitely going from a clear color to more of a light pink or rose color. That's the result we were hoping to see. Now we're going to add several drops of the potassium permanganate solution to well A3. This time we're not going to stir. As you can see, the reaction is going fine just on its own. It's giving us a brown solid in well A3. We are now adding about 2 milliliters of sodium sulfite solution, 0.2 molar, to well plate B2. We will rapidly stir it to see if we can get the results that we want. After several attempts of this, adjusting not just the potassium permanganate concentration, the sodium hydroxide concentration, and the sodium sulfite, what we're learning is that this manganese ion is very difficult to form. This should be a green color, and we're not seeing a color change here at all. So in your data table, please record that well plate B2 should have changed to green. If you notice a color change in well plate B3, that is because we added 50% concentrated sodium hydroxide solution, which changed the color to a very dark violet or dark purple color, which is the results that we anticipated. Here are your final results. A1 is clear, A2 is rose colored, A3 has a dark brown solid, B1 is purple, B2 was supposed to be green, and B3 is a dark violet color.